Alright, welcome back to the channel. My name is Lian Duan, and I'm a content creator based here in Maryland. My goal with the channel is to be a resource to DevOps critical thought, tutorials behind the screen content, and honest podcasts. If you're into the sort of thing, make sure you subscribe to join the creative crew. It goes a long way toward supporting this channel, and it makes sure that you never miss out. All videos related to Markdown and access YAML files are on my GitHub. The links are below. I started new videos for Kubernetes Security on DevOps view. So far we learned Kubernetes role-based access control and how to use RBAC to fix Elasticsearch stack deployment issue. I run hands-on demo how to find the minimum-based Docker image, reduce OS packages, and use Docker multi-stage build to enhance Docker image security. Also, I show how to run Docker containers as non-root user to avoid privilege escalation. And then we use Sneak to scan Docker image and went through how to fix Docker image vulnerabilities. Today, we are going to be talking about how to configure Kubernetes resource quotas. Video topic is my hands-on demo environment. What is Kubernetes resource quotas? Why do we need Kubernetes resource quotas? How to configure resource quotas in namespace? How to apply resource quotas in pod? First topic, my hands-on demo environment. The OS version is Ubuntu 22.0.4, long-time support version. The Docker version is 20.10.16. I log into my demo box, run the Docker version command to verify. The version is highlighted. Let me run minikube space version command to show my minikube version. Minikube version is 1.25.2. Java app Docker image from video. How to install Elasticsearch, Kibana, Logic Stash, FileBit, and Java app on minikube. I will add the resource quota to the Java Docker image. Close terminal and move to next topic. Before we jump into the hands-on demo, let's go to what and why. Next topic, what is Kubernetes resource quotas? There are three quota types: compute resource quota, storage resource quota, object count quota. CPU and memory are under the compute resource quota. Requests define the minimum amount of resource that container or namespace need. The limit is defined the max amount of resource that the container or namespace can consume. For example, limited memory is 3 gigabytes and the request memory is 1 gigabyte. Compute resource quota can add to namespace level and pod level. Next, storage quota. Storage quota is only for namespace level. Request storage config for the total storage capacity in the namespace. Total persistent volume claims are controlled by persistence volume claims parameter. Total Kubernetes objects set up via object count quota in the naming space, such as service, pod, replica site, etc. And then we move to why do we need Kubernetes resource quotas? Usually, the Kubernetes classes share to multiple teams. If insufficient memory resources are allocated, the application would be out of memory or crashed. There's other scenario. Without the proper plan, the provisioning of new pod used for testing could lead to other team application outage. In one common case, if a pod is stuck in pending stage, that means the pod cannot be scheduled on a node. Generally, it's because the node do not have enough resource, such as CPU or memory. The command kubectl gets nodes used to check node resource status. After we know resource quota types and why we need the resource quota, Kubernetes resource quota can apply to two levels, namespace and pod. We go to hands-on demo. How to configure resource quotas in namespace. The chart shows a Java app log is monitored by an Elasticsearch stack. If you are interested in the Java log monitoring system, please click the video link. Java log monitoring system has two namespaces, app and elk. I'll demo apply resource quotas and add limited range to the app namespace. This resource quota, compute quota, storage quota, and object count quota are added to the resource quota object. Resources quotas are in the heart of spec section. One resource quota is for one namespace. Their detail: request CPU is 1, request memory 1 GB, limit CPU is 2, and limit memory 2 GB. Also add persistent volume claims, value is 4, and then add for object count quota. Pods is 4, replication controllers is 4, secrets value is 4, and services value is 1. Resource quota config is straightforward. Next config item is limited range. One limited range applied to one namespace. Limited range works only for compute resource quota. It's not for storage resource quota and object count quota. The limited range admission controller enforces defaults and limited for all pods. If pods do not have resource requests and limiteds, limited range will ensure pods do not exit resource over limiteds. If pod resource requests over limited range, you will see HTTP status code 403 forbidden. If a pod resource lower than limited range value, the pod resource kept to original value. Limited range do not affect already created resources. The detail is in spec limiteds. Default memory is 512 megabytes. Default request memory is 256 megabytes. Resource quota and limited range are in quota limited range.yaml file. Create command is kubectl apply -f space YAML file name. Let me copy paste and run. Go down to the YAML folder, open the integrated terminal, apply the file. Next item, check resource quota. Run kubectl get resource quota space quota name namespace app output format YAML to retrieve resource quota detail, which one we just created. This information. Also, you can run that command kubectl get limited range to get limited range detail. Same command, no difference. If you run the command and face any issues, let me know. Namespace level quota completed. Go down to the pod level. How to apply resource quotas in pod. Request memory and CPU and limited memory and CPU are added to the pod spec. Detail is highlighted. All the values lower than the limited range. Deploy command is kubectl apply -f plus YAML file name. Copy and paste to run. Open my terminal. Deployment resource created. Pod should be created. Let me check it. Open Kubernetes plugin in VS Code. Check namespace. Switch namespace to app namespace. Open workload to see the deployments. Deployment object is created. Check the pods. Java pod is created. There is no issue. We close the terminal. If we create a pod resource over namespace configuration, what happened? Let me try that scenario. Request memory is 1 GB, CPU is 3. In the same value in the limited configuration. Since I didn't change the pod name and the deployment name, let me delete current deployed resource and the pod first, and then run kubectl command -f plus app log generated deployment v2.yaml file. Deployment created. That means the deployment request submit to the API server. Let me check the status of the deployment and pod. First, check deployment resource status. As I mentioned before, if we created the pods over the namespace resource value, you will see forbidden. This message highlighted. deployment resource created, but pod resource cannot created, since the resource over the namespace config. Close the terminal. All topics are completed. Today I shared how to configure Kubernetes resource quotas in namespace and pod level. Thank you for watching the video. I hope it was helpful, and it was. Do not forget to like it. If you want to be notified when a new videos come out, then subscribe to my channel. If you have any questions or something was not clear in the video, please post them in the comment section below. I will try to answer. Thank you, and see you in the next video.